Hello friends, this is Vahid from QVERIFY Education and welcome back to our QTest series. In the last episode, we set up our testing environment and wrote our very first tests. Today, we are going to level up. We'll talk about two very important concepts in unit testing, fixtures and data-driven tests. Fixtures let us prepare a clean setup for each test, so our tests don't interfere with another one. And with data-driven tests, we can test multiple input and output values with just a single function. Keep our code clean and scalable. By the end of this episode, you will see how to write tests that are independent, repeatable, and cover many scenarios with little efforts. So let's jump into Qt Creator and start our journey. Well, this is our project that we have created so far, and I named it TDD episode 01. I don't know why, because I'm just working on this and add different commits for our repository, so it's not important. Here we have two different modules. Our real module, the module that contains our business class. We have a calculator class that contains 4 different operations here, and also here we have our test module, and also we add the source of our calculator here to be able to work with that. And inside here, we have a couple of different methods, different private slots. And by the way, if you haven't watched the previous episodes, I recommend you to watch them first and then continue on this one. So these private slots are our private cases. As you can see inside them, we created a calc class most of the time, calculator class, and then do some operations and some verification or compare we just did inside these methods. So let's just comment these methods. I don't want them anymore. And I want to run the tests. Let's run this project. And here we have 1, 2, 3 methods. But as you can see, we have 5 passed slots. So init test case and cleanup test case. These are 2 extra private slots that QTest framework used for test fixture. So by using text fixture, we can do some setup and also some resource release in our tests. As you can see here, we just instantiate our test, our business class a couple of times, also here and in the other test methods. Now imagine I want to work with a pointer, and do some initialization and things like that. So we need to do that here inside each method, but using our init and cleanup method, we can do this automatically. What does it mean? So I'm gonna create another method here. Void. I'm gonna go init, and inside this, I'm gonna do what? I'm gonna create our calculator instance as a pointer inside the test class, and inside the init, I'm gonna say, okay, please create an instance of this class for me. Okay, and also I'm going to create another method named void cleanup, and here I'm going to delete the calc and set it to null ptr. Now for every, let me also comment this calculation declaration here, and this time I'm going to use this dash greater sign, so I can access to this instance here. But as you can see, I'm not gonna initialize or instantiate this calc field inside these methods. This will be done automatically inside init method. And QTest framework will automatically call init and cleanup after each test case. Let's see the result of the test. So as you can see again, we passed all the cases because right now we just do our data preparation inside the inside the init, and also for cleaning up things we can use this method. So cleanup we use for resource releasing, and inside init we can do some initialization. So it will help us for real scenarios. Instead of initializing our object inside each single test case method, we can do it inside init method. It's just like a factory method. We just remove the initialization from our test case and move it into another method. So this is the first part, and it's very helpful if you want to do real tests. The next item is when we want to use data-driven tests. Imagine I want to run divide test, this one, test division. I'm going to create another one for more than one pair of data. For example, I want to test for 5 items or 10 times. Instead of calling them 10 times or create 10 different methods, I can do it in data-driven mode. So here we need to be familiar with the concept of columns and rows and then fetch them. What does it mean? I'm going to create a method named test divide, and here finally I'm going to call QCOMPARE, and as for the actual value I will use the calc.div method, and I don't have a and b right now. I'm gonna just pass a and b and another value named expected. So this is the final things that I need to have. This is the ideal case for me. Now I'm going to use another micro named QFETCH, and it says please provide the type of the data. I'm going to say it's int, and put the data inside the variable named a. Okay, and I'm going to duplicate it a couple of more times, fetch another int values and put it inside a variable named b, and finally put something inside expected. So as you can see, all the errors gone. So using this, I'm telling the QTest, okay, for test divide method, this one, I just provide data for you. Go ahead and iterate over data and run this test as far as you can. As far as you can retrieve some data. So for preparing data, we need to do what? I'm gonna copy this line. You need to follow this notation. Add underscore data to the name of the method that you want to provide data for. So inside the QTest class, we have a method named addColumn. So for addColumn, we have a bunch of, it's like a spreadsheet. We have a couple of columns, A, B, and other parameters that we have, and also expected value for each rows, and then we add some rows of data. So I'm going to say I have a column of type int, and the name is A. So let's duplicate it another 2 times, B and expected. So these are the names that I use here. These were defined here, A, B, and expected. Now I need to pass or add some rows, some real data to these columns. Just imagine it as Excel spreadsheet file, okay, Excel sheet file. So I'm going to again use QTest, call another method, a static method named a newRow. So here I'm going to say the data tag. This is a message for our test. It's 10 divided by 2. So what is data? It's just like adding data to a list. So I'm going to say 10, 2, and expected value is 5. Let's do it a couple of times and change the values. 9 divided by 3. 9 divided by 3. It should be equal to 3. And also 9 divided by 2, and this is because integer division, so it will be 9 in the quote. Let's change it to 4, and 4 should be 2. So that's it. Now let's run the test and see the result. So as you can see here, we have test divide 10 by 2, 9 by 3, 9 by 4, and all of them passed because it's okay. And if we just change one of them, for example, this one to expected value to 4. Oops, I run the whole application. Let's run this test. Run this test. And this time, as you can see, this one passed, but this one just failed because compare values are not the same, and actual value is 3, the expected is 4, and the location of the errors, and this one again passed. So we have 7 passed and 1 failed items here. So this is the way that we can provide data for our test divide. Also, we can read the data from files. Do it by as a practice on your own. One more important thing that we need to do inside the real application is when we throw some exceptions. Most of the time in code we throw exceptions, or other libraries throw exceptions, and we need to handle them. So in test cases, there's also a way that we can do that. For example, here I'm gonna create a test divide by 0. In previous session, we just implemented in this way that if we want to divide something by 0, just return 0, not throw any exception. Now this time we're gonna expect exception thrown from our business class. So here we have a micro named QVERIFY exception. QVERIFY exception thrown. This one. Now I'm gonna say calc.divide 10 by 0, and it should be equal to std.runtime error. We will throw these exceptions. So right now we are inside the ready state, and well, it says it's deprecated. Let's just use the other one. You throws exception. What is the parameter here? Our exception type. Okay, and well, we need to handle it in another way. So okay, let's just use the duplication. If you see it somewhere, you're now familiar with that. So right now we are inside the ready state. Now let's get into the divide method. So if it's equal to b, our second parameter is equal to -1, I'm gonna say not return, throw std.runtime errors and if by 0, something like this. So it's okay. Let's run the test. So as you can see, for test division by 0, we just passed because we are expecting that exception, and we received it. And if we change it, for example, to 10 divided by 1, this time we are getting into ready state because it's a valid division, and we don't need to throw that exception anymore. So as you can see, divide by 0, expected exception of type this one, and to be thrown, but no exception caught. In Qt6, this micro is getting deprecated, so we can just use the other one. QVERIFY throws exception, and we need to just replace the position of these two parameters. First, we need to pass the exception that we are looking for, and then just the real operation. So let's run the test once again. Come on, come on, come on. Well, again, as you can see, test division by 0 is passed, and if we change it to, for example, 1, this time test will be failed, and the exception and the message maybe is like the one that we just saw, failed, accepted, exception, blah, 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 blah. So these are the different ways that we can handle test in our code by using init and cleanup method, and providing data for our test. As you can see, if I change this one, this one here, then this shouldn't work, because the notation is this one, adding underlying data to our test method when we want to provide data, using addColumn newRows to define the data structure and also provide data for each row, then fetch them, and then use QCOMPARE or QVERIFY, sorry. And then we can also check for exception using QVERIFY exception thrown. This is for Qt version 5, and in Qt version 6 we should use QVERIFY throws exception when we want to looking for exception during a code running. So I hope you enjoyed this session. Till next session, goodbye.